Let's jump into the first topic addressed by the BQ40Z80, supporting battery packs with more than 4 cells. The BQ40Z80 supports up to 7S packs, but it takes a little work to get there. If you are only doing a 5S or 6S pack, then your setup is straightforward in that you connect the cells directly to the ADC through the resistors, not shown in the simplified schematic, and using the cell configuration register to configure it for 5S and 6S. However, for 7S, since there isn't a VC7 on the device, the top of stack and cell 7 is measured by configuring 2 multifunction pins to achieve this function. Pin 15 is configured as VC7 enable, which controls duty cycling the external resistor divider to save power. Pin 12 is configured as VC7 sense to have it be the ADC input, so that information is used in calculating the voltage for BAT and cell 7. These pins are configured in the configuration register called pin configuration. Pretty simple, right? The BQ40Z80 EVM default settings are for the 7S cell configuration. This chart shows the default configuration for the other multifunction pins. Pin 12 and pin 15, as mentioned, are used to configure for 7S. Pin 16 is used for external cell balancing for the 7th cell. I'll go into more detail on that in a bit. Pin 13 is used in conjunction with pins 20, 21, and 22. Pin 13 is the display input, which is connected to a push button that, when pressed, lights up the LEDs to display the state of charge. I'll also go into a bit more detail on that later. Finally, pin 17 is configured as a pre-discharge pin, and you guessed it, more detail to come. In the BQ40Z80 EVM user guide, there is a lot of good information on how to configure the EVM. When using the EVM, you may not have a battery pack ready to use, or you may want to use a power supply as a battery stack. A simple way to do that is to connect resistors between the VC terminals and then place the voltage source from ground to the top of stack. When doing this, you won't be able to source or sync, but you will be able to see the voltage measurement at each cell and configure and calibrate the BQ40Z80. The EVM guide has a simple table that shows you the configuration for each multifunction pin with the corresponding register setting, jumper connection, and any additional comments to help get that EVM set up correctly. If you are using less than 7S, then short together the higher cell terminal block connections on the EVM as shown. When using BQ Studio, you configure the settings in Data Flash. To do this, go to the Data Memory tab, then go to the Configuration section, and then to Pin Configuration. You can set the multifunction pins to the desired function. As mentioned, the default configuration is to have VC7 Enable and VC7 Sense configured to be used for enabling and measuring the 7th cell. You also have to have the cell configuration reflect the number of cells used in the system. In this case, it is shown to have setting 7, which means a 7S configuration. The TRM provides information on how to read information about voltages, currents, and powers for all the cells. A new manufacturer access command returns the information for cells 5 through 7. However, we provide the BQ Studio graphical user interface to simplify this for evaluation. Using BQ Studio, go to the Register tab, then scroll down to where the cell voltages, cell currents, and cell powers are displayed. You can also use BQ Studio to log this data for analysis. To calibrate the device, you can do it manually following the process in the app note for the BQ40Z80 manufacturer production calibration. No CC offset calibration is necessary on the BQ40Z80, but just in case, the app note has how to do that. Also, there should not be an onboard offset calibration required either, but again, just in case you experience that in your system, we have detailed instructions on how to perform that in the app note. An easier way to do all the calibration is with the BQ Studio GUI. When you click on the Calibration tab, a window will pop up that shows all the calibration options. The device firmware comes programmed with a value that is likely close to the final gain value, but it needs to be calibrated to your specific board. The instructions for calibrating the current are simple. Connect and measure a 2 amp current source from one end and pack to calibrate without using the FETs. TI doesn't recommend calibration using the FETs. Enter minus 2000 for minus 2 amps in the applied current field and select the Calibrate Current box. Press the Calibrate Gas Gauge button to calibrate. Deselect the Calibrate Current box after current calibration has completed. Calibrating voltages is also needed and can be accomplished on the same calibration tab. All of the voltage calibration can be done at the same time. Measure the voltage from 1P to 1N and enter this value in the applied cell 1 voltage field and select the calibration voltage box. Measure the voltage from 6P to 1N and enter this value in the applied VC6 minus VSS voltage field and select the calibrate voltage box. Measure the voltage from PAC plus to PAC minus and enter this value in the applied PAC voltage field and select the calibrate PAC voltage box. If the voltage is not present, then turn the charge and discharge FETs on by entering the 0x22 command in the manufacturer access register on the register screen. If the device is configured for 7S, measure the voltage from 7P to 1N and enter this value in the applied 7 cell or applied cell 7 positive terminal voltage field and select the calibrate battery voltage box. Press the Calibrate Gas Gauge button to calibrate the voltage measurements. Deselect the calibrate voltage boxes after the voltage calibration is completed. Note that calibration of the temperature sensors can also be done as well. The BQ40Z80 has up to 4 TS inputs, and all that can be calibrated on this screen.